me, don't worry. Okay, we're recording. And I'm going to share my screen. All right. So thanks for joining. And some of you I may not have met because we, of course, have been growing and evolving as a division in an area over the last year. And for those of you who I haven't had the pleasure of meeting in person, welcome, and I look forward to doing so in the near future. So I have two titles. I'm the Director of Climate and Ecological Sciences here at Berkeley Laboratory. And I'm also a full professor, but what's known as a professor in residence with Earth and Planetary Science at UC Berkeley. And I'm happy to have grad students as part of my research group, both from EPS and also from astronomy from campus. And speaking of astronomy, I started my career as an astronomer. So this is a younger version of me over here on the left. This is the interior of the Yerkes Observatory, which is up in Wisconsin. This is the was before, this is now a resort, but when I was a grad student, it was the world's largest refracting telescope, 24 inches wide, and was used by astronomers. This is a convenient driving distance from the University of Chicago to make observations of the night sky. And my research focused on this movie thing, the transfer of energy from the solar photosphere to the corona. And you can, this movie is from a NASA instrument. It's designed to illustrate how dynamic a star the sun is. One of the other things that I really enjoyed about working up at Yerkes is that it's right next to a lake where we would go swimming, and the town nearby had just really superb ice cream from all the dairy cattle that lived nearby. So it was, there were a lot of reasons to enjoy being an astronomer up there. Once I finished my PhD with Professor Eugene Parker, and he just recently had a satellite named after him that's now probing the sun. I switched fields to climate and began work on climate. And the motivation was that I had grown up really enjoying the outdoors and wanted to advocate for the environment. And one of my mentors in grad school said that you can't be good at both. You can't be both an advocate and a professional scientist without thinking about how to make those part of the same thing. So make them part of your day job. And so I decided to switch to working on the environment as part of my day job. And this just sort of illustrates, being outdoors. Actually, there are a couple, Andy Jones is on the call, I see. This is Andy just to my left, and Travis O'Brien, who was here at the time and has since moved to Indiana University to my right. This is a summer school that Andy, or summer workshop that Andy arranged to talk about how to understand hydroclimate and the intersection between hydroclimate, our understanding of hydroclimate, and practitioners. And it was a really phenomenal summer workshop that we held up in Aspen. So this is an example of getting outdoors and also doing good work and doing some good hiking at the same time. And subsequent to joining Ramanathan at the University of Chicago, I worked at these two places. So one of them, the first place that I worked is the Scripps Institution of Oceanography. And this is the pier at Scripps. It's based in San Diego. I was a research physicist there for 6 years and wrote my first controversial paper when I was there on a theory about how the climate could be regulated by clouds as kind of a thermostat. And then moved in 1996 to the National Center for Atmospheric Research in Boulder. And this building in the upper left is NCAR. This is the Mesa Lab. It was the first big commission from the architect I.M. Pei. and it was designed to resemble Pueblo dwellings from the first Americans who lived in the American Southwest. And people are seeing this slide, right? I had trouble. Can people see a picture of the Earth? Okay, good. This animation screwed up the last time I played it. But then the point of this is actual imagery from NASA, and then moved to the Bay Area. So this movie, which may be sort of doing a stopgappy thing on your screens because of bandwidth limitations, what it does is it zooms in. I'll stop it. It zooms in and ultimately focuses in on Pier 33 in San Francisco, just to sort of illustrate my move to the Bay Area, where I've been since 2013. And I was brought here, I should say I was recruited to come to Berkeley, both as a scientist, but also help launch a climate activity here at Berkeley Laboratory. And so I'll mention those two aspects of my career since I moved here. And it's been interesting. It's sort of a good example of, as people who know the timestamps of my email, burning the candle on both ends. So so you should be seeing a slide that says life as a division director, and Tracy, you're nodding, good. Okay, so I moved here in 2007, and at the time when I moved here, the head of the person who now corresponds to Gary, who is now Gary Gernhardt, the division director for biological and environmental research, said, "Why did you move to Berkeley Laboratory? We've already got climate covered at the other DOE labs." And that was kind of a somewhat disturbing message to hear. But we kind of took off during the Obama administrations and grew to about 100, and then launched the division. And so this just sort of shows the rapid growth in funding. So grew by a factor of 4 in the space of in terms of the number of dollars, and grew by a factor of 10 the number of people, and had a great time kind of launching this division as an intellectual entity, and the sort of the $45 million a year enterprise that it is today. So that's been really great. And I should have mentioned that the other thing I've been very proud of is despite the fact that I've aged by 13 years since moving here, the division hasn't aged. So how you've pulled that off, I'm not quite sure, but the median and mean age of the division has stayed under 10 years from PhD over its inception. So somehow, somewhere, somebody's got a fountain of youth running. But it doesn't, I haven't been privy to that fountain of youth. So I'm looking for, I've been searching for it while I've been on site, all by my lonesome. One other thing that has evolved, as I've aged, is the amount of carbon dioxide in the Earth's atmosphere, and this is pertinent to my role as a scientist, and it also gives me a good opportunity to show my evolution as a human being. This graph is the evolution of greenhouse gases over my lifetime. So I was born in 1959. So I'm now 62 years old. And carbon dioxide, and this curve was developed by Charles Keeling, who I met when I was at Scripps. He worked at Scripps. He had to fight like the Dickens over his career to keep from this measurement being turned off. And what it's showing us, of course, is that CO2 has risen because of anthropogenic influences. And this sawtooth pattern is due to the annual cycle of photosynthesis and respiration due to the natural impacts of the terrestrial ecosystem on carbon that occur every year, of course, because and this cycle occurs because most of the landmass, where most of the plants are, is in the Northern Hemisphere. So we're sort of looking at the impact of boreal forests on the carbon cycle. Okay, so here's my baby picture. I'm not going to blow this up for your amusement, but this little infant that's Photoshopped. This is Photoshopped literally using before Photoshop existed as a thing. This is me in diapers, circa 1959. My mom and dad and my uncle are standing up. My grandparents are seated, and my 3 siblings are all on their laps. So this is me sort of Bill, version, the alpha version of Bill, I suppose. And here's me in my current instantiation. And CO2 concentrations have increased by 25% in my lifetimes. This is something I've been working on as a scientist for a large portion of my career. And I would say probably the graph for which I'm proudest is this graph. And I'll stop the animation just so it can get over the internet tubes to your screens. This graph is something that Dan Feldman and I and some other co-authors, Margaret Torn, published in Nature in 2015. What it's illustrating is the close connection between the rise in CO2 and the rise in greenhouse gases. So you can see both that it's rising, but what are the three important things about this graph are that it's the first time.
突然停电了，我
Yeah.
对你先不用管。
Everybody needs to remember to mute, please. It's the first time that we had actually demonstrated the CO2 effect in the wild. We've known about it theoretically since the work by a Swedish scientist named Arrhenius in the late 19th century. We've known about it from laboratory spectroscopic measurements. We'd seen evidence of it from satellite, but this is the first time it actually had been demonstrated from field measurements. Since it was thought of by Arrhenius in the late, literally 130 years ago. It's the first time that we'd shown the close connection year by year between CO2 and the rise in the greenhouse effect. And it was the first time that we documented the magnitude of this natural swing in the greenhouse effect due to this natural cycle in photosynthesis and respiration. And so Berkeley Lab, basically the summary of this is that Berkeley Lab expects division directors to lead by example. And so I've been trying to eke on a career as a scientist while also trying to run the division, which is pretty much a soup, as Tracy could attest, pretty much a soup to nuts, deal. I get called into, on a lot of different aspects of keeping the place running as kind of a mechanic under the hood, if you will. All right. Last couple of slides here. We've got a lot of exciting science ahead, and I wanted to kind of reprise my career as an astrophysicist by showing you, since the Hubble Space Telescope has also just had a major anniversary. This is one of its famous photographs known as the Pillars of Creation. This is a nebula. I think there's a lot of great science ahead. So I'm really excited to be working with you on that, including work on climate, work on figuring out how to sequester carbon, working on trying to connect machine learning to what we do, figuring out how to do all this in partnerships, both new and existing. So that's cool, and that's fun. Outside of work, I'm very happy to have a wonderful set of companions, my wife Jan, who did not give me permission to show her picture, but my constant canine companion who didn't know that I was going to show his picture, but here he is. This is Shadow, a 92-pound German Shepherd, and who's gotten extremely used to my being at home. I'm not sure what he's going to do if we go back to our normal work lives. This was not a question on the recent poll, by the way, so that you may have gotten a poll from the laboratory asking you about work life before and after COVID. There was no question about how our pets feel about this, which I think was a major oversight. Anyway, Tracy's nodding because she has a gigantic dog at home as well, who's also gotten extremely used to having her around. Anyway, with that, let me conclude, stop screen sharing, and we can talk about, I'm open to any questions you might have, and I'm looking, you should be able to raise under reactions, you should be able to raise your hand. So if you go down to reactions on the very bottom and raise your hand, I'll be looking for it. Or you can unmute yourself and ask a question too. Far away. Tracy, I see you have your hand up.
Yeah, Bill, I thank you for that summary. It was really nice. Didn't know some of that stuff. But I'm curious about what you think, maybe this is a big question, but what do you think your biggest lesson learned as you've come along in this career has been for you?
Great question. There were I think as students, we're trying to think a lot about the what that we're working on, whatever that topic that is, and focusing a lot more on why has become, I think, a much bigger part of what I do, right? So I'm asking the why question a lot more now. And the other I was trained by a very old school, professor, right, who had had the same grant from the Air Force since the late 50s. And all the people skills that, and you can be the judge about whether or not I have any people skills, but all the people skills that I think I've had to acquire to effectively run a team-oriented, entity like the division, those were soft skills that, I had to pick up by osmosis. And that was a huge amount of learning right there. Just figuring out how to incentivize people, and how to work effectively with people from a huge, wide range of backgrounds. So those were probably the two biggest lessons. Okay, folks, this is going to work only if you help me with questions. So,
all right, I have a question.
Excellent.
I'm Reed. Hi, you haven't met yet. I look forward to meeting you someday. I started after the shutdown at the lab. I'm interested in how, I know you're interested in astronomy. How did you decide the path when you were younger that this is what I wanted to do? Did you have a mentor or someone who said, if this is your interest, if you like spending time outside and your parents have to tell you, Bill, come inside, it's dark, you've been out too late. Who got you on that pathway? Go, this is the direction to pursue. These are the courses you need to take.
Yeah, so I was a I was a really nerdy kid, and I built mechanical computers as a kid. My parents gave me a telescope, and I grew up in, as I mentioned, in Tennessee. So, and we had great seeing conditions there. So I was outdoors, as you mentioned, at night, staring up at the night sky. I am old enough to have witnessed the man landing on the moon, and also to have had a babysitter who didn't want to watch the television because she didn't believe that God would allow us to land on the moon. That was a thing with my babysitters. So I was really interested in science. Had a great physics high school teacher. Went to college determined to learn physics, had great mentors there. And yeah, I'm glad you asked about the mentoring thing, because that turned out to be, mentoring turns out to be one of those things where it's unfortunately for many people an accident. They just happen to be in the right room with the right person at the right time, and that person takes an interest in them. But oh my God, does it make a difference? And I imagine that we all have those mentoring stories, but it's that can be make or break for a scientific career. And I had a really smart, extremely sarcastic and somewhat politically incorrect high school physics teacher, and he was the one who got me started. Thank you for the question.
I don't mean to take up all the questions, but I know that some of the questions that have come to me from the mentees is, how is it that I think some mentees feel a little bit like it's a lot to take on their career development. Sometimes they don't know what they don't know, and they don't kind of know how to ask questions or where to go. Is there something that you could recommend to them? I mean, I tell them, don't be afraid. That's not a very specific answer to the question. Pursue where you don't be afraid to ask the question. But is there anything specific that you can sort of say to somebody who's in their early career to sort of focus on, or how they would approach their career development?
Well, I'll mention first that, fortunately, the unknown unknowns for me remained unknown for a long time. So I was blissfully ignorant about how to really construct an academic career, especially in kind of the modern academic meat market, largely because I'd witnessed my parents' generation come up in academia. And that was when money was being shoveled out the door by the federal government faster than people could spend it. And so when things flipped, which happened in the early 70s, around the time when I was starting, my whole model for how an academic career worked was based on what I had observed when I was growing up. And it turned out not to be the right model anymore. And I didn't realize that for a while. So I will say that sometimes not knowing, what you don't know can be helpful, because you know not to worry about it. I guess though, in all seriousness, to answer your question, it's really important to find something that you love, because it's going to frequently, to succeed in it, it's going to require a lot of work. And I know that work-life balance is constantly a struggle. Got you there, but it's so in the face of that work-life struggle, it's really important to find something that you love and want to work on. And also, I think the other lessons that I learned along the way were my thesis advisor told me that you'll succeed if you become the world's expert on X. But, so pick X and then become the world's expert in it. But make sure that you identify what X equals. And the other lesson that I learned, this is sort of an odd one, but I think it's one way of ensuring that you're constantly running quality control on yourself, is being your own worst critic. So the failure that I've seen in scientists, especially as they get more senior, is that they forget that lesson. And once you forget that lesson, you're done for as a scientist. Really, I've seen way too many examples of people who become settled in their careers, slightly too smug, and then they then nobody wants to listen to them anymore. So, yeah. But anything else at the early stage of your career? Mentoring is good. Teamwork is good. Thinking ahead, maybe not too far ahead, but thinking ahead by 3 to 5 years is good, and constantly keeping that refreshed. It's very easy to be fighting last year's scientific battle if you're not careful. And the thing that I struggle with now, Tracy, on the flip side, at my stage of the career, the flip side is getting up the energy to keep up with the latest trend. So let's take machine learning as an example, right? Every morning I'm like, I have to get myself out of bed and think, okay, I'm going to be really keenly interested in learning about this thing, but oh my God. Because there comes a point where you've seen it, you sort of seen stuff, rise and fall. I've been around a few scientific fads in my career. This one definitely has that flavor, and I'm trying to figure out what part of it's real, what part of it's a fad. So yeah, that is late in your career, you'll start to experience burnout, where it's like, do I really have to learn Python? Do I really have to learn machine learning? And you name it. But I'm getting a bunch of eye rolls now that unfortunately I can't see. But all right, so I've got a question from Kripa and then Matthias. So Kripa, you first.
Thank you so much, Bill. Can you hear me?
I can, loud and clear.
And sorry, I can't turn on my video. My internet is really bad. And I think you already kind of answered my questions, but I'm still going to ask it and see if you have something else. I was going to ask, what would you tell your younger self, maybe 15, 20 years before, to not worry about, that you worried about too much, that you think isn't as important today, or anything that you would have told your younger self now that you have had so many years of experience. And then here's another one. I think maybe I'm reading too much into it. In a lot of what you said, you also were saying, you know, people had culture, or institutions had culture that was quite different from how you are today. And that's something that I think a lot of us pick up on and learn from, that, you know, you embody things that we didn't know were okay in the academic institution before, but are you know, evolving right now. And I assume we're going to evolve our institutions as we get to know more and more issues, especially, you know, diversity, inclusion. We're going to have to evolve institutions, but sometimes it's difficult as younger scientists to not see this as a roadblock. So how would you, what would be your advice to younger scientists like us on how we can help to improve and evolve our institutions to become, you know, better?
That's a great question. All right, so let me, your first question, what would I have told myself not to worry about? It may shock you that I have suffered from imposter syndrome, you know, at various stages of my career. And I think, you know, if we're all honest with ourselves, we probably have all suffered from it. And I definitely felt that. And I think in some ways, you know, that can be a healthy impulse, but there were times when it became almost crippling. And so I would tell myself not to worry about it so much. I think the something else that I realize now, sitting from where I sit, is that the people, you know, around you who, you know, who are leaders in the field are still people, still put their pants on one leg at a time. I can assure you I do. And what we hunger for is not, you know, so much power, but actually the chance to, at least I hunger for the chance to collaborate with people without any power dynamics kind of running in the way. So that was not, you know, that was not apparent to me early on when I was looking up to people who looked like they were on the top of Mount Everest. And you know, and so I just remember that the people that at all career stages are very keen to actually be treated as working scientists, and nothing thrills them more than be treated as working scientists by people who are younger and are entrepreneurial. So to your second question about institutional change, that is very important. And you know, when I got here, the term family friendly, I didn't hear it at all from the first lab director for the entire time he was in, you know, he was in that role. I think we have seen a change for the better as I've been here, and a much greater investment of in trying to build, really institutionalize, and I mean institutionalize in the best sense of the word, recognition of how important it is to be inclusive within the institution as a value proposition, and as a means of both, you know, both individual and institutional transformation and growth. I would say that the biggest challenge lies probably not with, well, probably it lies within our walls. I've become convinced that one of the reasons why we have trouble hiring a more diverse pool is that we've not opened up our mission to be more inclusive. I mean, we have a mission statement, but that mission statement to the outside world doesn't seem sufficiently inclusive. And so for that reason, people don't see themselves as being, they don't see how they can contribute to our mission. So we actually need to rethink our mission statement as an institution so that becomes more inclusive. And I think the other dynamic that's going to happen, Kripa, over your career and perhaps less over mine, is that the climate, climate's going to become a lot more like a permanent health crisis. And so the way that we engage as climate scientists with the outside world is going to just, it's going to become very different academic, and I think it will mean that our roles will become richer, but also more demanding. And how we embrace that as a form of change is something that I think will be something your generation will face much more than mine. So good luck with that.
Thanks, Bill.
You're welcome. Matthias, you had your question, hand up, and then Charu has her hand up as well. Matthias.
Hi, Bill. Yeah, thanks. The question that I had picked up at your last comment, and it's about the why that you said that became more and more important, and seeing how the public response to like scientists during the pandemic doesn't make me very optimistic about our response towards climate change. So do you have any additional comments with that regard, other than good luck? And sorry, and the second question is, so you are obviously very successful, which comes a little bit as a survivor bias, right? So do you have anything that you told people who had to leave the national lab or who chose to leave, what they could have done differently to be more successful and not have to leave, for example?
Oh, wow. Okay. So on the first point, there's tons of social science that's been done both in academia and now is being done by, of course, by the Facebooks and Googles of the world, along with advertising companies, that illustrates how to alter people's opinions, right? And so the IPCC, is is like a card punch compared to how we should actually be trying to influence public opinion around climate change. It's utterly useless as an instrument for influencing climate change. I mean, just utterly useless. So we are going, one of the things that we will have to figure out how to do as a community is how to use what's abundantly known by the commercial world about how to alter people's perceptions of themselves in a way that's positive and that also embraces science. How we do that with, while maintaining this fictitious sort of line between the observer and the observed, I don't quite know, Matthias. It's a very tough question, but people don't resist climate science because they're stupid or because they're ill-educated. It's because it doesn't accord with their belief systems, and those belief systems are as integral to themselves as, your and my belief in Enlightenment, which I suspect we would be very loath to give up. So that's something we're going to have to figure out. And again, that is straying outside, it's sort of coloring outside the circle of what we're supposed to be doing as scientists, but we're going to have to do it if we're going to be successful in communicating. To your second point about leaving the lab, there are, look, 3/4 of the physics PhDs in this country, at least, in the American Physical Society, go on to jobs outside of academia. So they go on to work in industry. Most of the time that I've given counseling to people about leaving the lab, it's because they needed to make a choice about work-life balance. So I've advised people that I felt that their family life was more important than their job as a scientist. I got extreme flack from their PhD advisors about that, but I still gave them that advice because I felt, honestly, that they would be happier if they figured out a way to, for them personally, if they figured out a way of balancing those two competing objectives. And obviously, I'm just, you're wrestling with that question as well. And I've also had situations where people, have had to eat my words, and people became very successful and they left the lab because they got great, jobs in universities. And I've been delighted when that's happened as well. There have been, the hardest thing though, Matthias, to your point, is that I'm I am a stickler for quality in scientific output. And I have hired to a type within the lab, which is that I want people to be successful both at the lab and also in the academic job market. So I don't want people to be stuck here because they can't succeed in the outside world. That is very different from other national laboratories, I can assure you. And I've run into issues where that is run directly into people's expectations that they've been here for a while and why aren't they sort of more or less falling into the next stage of their job career here. And that's been a tough conversation. But just to be very clear, I want people to be here because they've looked at the outside world and they've decided that the grass is greener on this side of the fence than on the other side of the fence, not because the only place the way they're viable is here. And again, that could be a tough conversation to have. Learning how to have that conversation with people with a tissue box nearby has been one of those people skills that I've had to learn. But thank you for those questions. Charu, let me turn to you. You had your hand up.
Yeah, Bill, thank you so much for sharing. This has been great. So I had a couple of things kind of following on just what you just said. You know, what it struck me was how you had sort of migrated different institutions before you landed here in Berkeley Lab. And I was sort of curious, you know, as to whether that was a good thing and how much you absorbed from different institutional cultures, because many of us have been, you know, at not gotten that kind of a rich sort of set of experiences. And I was just curious what you learned. I also saw that you had sort of switched disciplines, and how did that go? Because there's so much you have to learn and catch up on when you do that. And there was, you know, to become as successful as you've been in your new field, you know, sort of, are there sort of advice that you would have for how you absorb information? We're all facing the bandwidth challenge, learning new things.
Yeah. Well, the second question, let me deal with that one first. The second question is the reason why I've pivoted from what to why. Right, because you know, it's much easier to apply, and I think part of this arose, Charu, because I'm now faced with trying to assimilate all of your scientific output. So I've had to figure out how to get to the kernel of what you're telling me as quickly as possible. And so, you know, I run it through a very simple paradigm in my head, like, you know. And I sort of match what you're telling me onto this paradigm of 5 questions, and most of which are why questions, to figure out if you know, if to understand what you and other people in the division are telling me, and that's turned out to be an incredibly useful way of framing what I do as a scientist as well. So, so the weird thing is by coming here and being faced with having to spend very short snippets of time with a large number of people who are telling me a lot of different things about the science they're doing. That's actually made me a better scientist. You'd think that it would be sort of temporal deficit disorder all over the place, and it is that, but it's also taught me to get to the nugget of the nugget of a scientific argument much faster. Because I used to be obsessed. You know, I sort of had this problem set mentality. Like, if I can't derive what somebody's telling me from the fundamental equations, then I'm useless. And now I've just sort of, you know, that's way in my rearview mirror at this point. To your first question about switching institutions, well, you had 3 questions. That's been useful, partly to see the things that I learned from those institutions were that actually both Scripps and NCOR had very dysfunctional power dynamics, where tenure as its practice in a university, so, you know, created a gigantic amount of very senior people who were incredibly entitled. And what I appreciate about Berkeley Laboratory is this sort of like, we're like sharks. We only breathe if we're swimming, right? So that we've avoided that that trap that both Scripps and NCAR especially have fallen into, I'm sorry to say, as institutions. And I mean, they're both phenomenal research institutions, don't get me wrong, and, highly storied, have got, incredibly, list of laureates and at least at Scripps, people who've done Nobel Prize worthy work. But I moved from each because I felt like I had run out of headroom intellectually. And so I'm, the last thing I will say, and it's sort of in response, it may be kind of in response to, I guess, more to Kripa's question than to yours. It has to do with institutional change. One of the things I'm very conscious of is making sure that all of you have a chance at leadership roles. And that also means that people like me who are sitting, at this sort of apex of the pyramid get out of the way eventually, right? So, and that's the reason why I stepped down as being department head, because I wanted somebody else to take on that role. And while I'm, also why, it's also the reason why I'm having very active conversations now with the division council around succession planning for me, because I want to make sure that somebody else can step into this role sooner rather than later, so that somebody else gets a chance of running the division and seeing what that's like. Because I think we become stronger the more that we all understand what it is to be a good scientist, but also what it means to contribute to institutional health and to mentor and to grow a program. All those things, make us stronger. And the more that we democratize that knowledge base, the stronger we are as a division and as an institution. So yeah, somebody said to me that your job as a leader is the first thing you should do, or maybe the second thing you should do, is start thinking about who's going to succeed you. So that's one other lesson to think about. Let me take a Wan-Ping's question, then Colby's, and then I know we're at time. I'm happy to continue until 12:30. For anybody who wants to stay on. Wan-Ping, you have the floor.
Okay, thanks, Bill, for the insights. I have one questions. Probably which is very common among early career scientists. Nowadays, this is a more connected world. You got lots of requests, and there's a lot more leadership roles you can take, like editor or reviewer and other many things. On one hand, we want to expose ourselves to the outside world to get more collaborators. On the other hand, we also want to focus on our work. So my question is that, do you have any recommendations on selecting what kind of roles to take?
That's, it's a really good question, Wan-Ping, and I know that time management shows up over and over again as an issue on people's annual performance appraisals, and everybody, including me, wrestles with it. And there's so many different ways that manifests itself, both in terms of unpaid service. So, for example, IPCC, which is unpaid and is essentially a volunteer activity, being a reviewer, and unpaid activity, writing grant proposals and so forth. The answer to your question is not one size fits all. It definitely has to do with career stage. So people who are at the beginning of their career gain credibility by gaining the respect of people, throughout the career ladder, because it's clear that you're a good scientist, right? And that creates latitude that you can then exploit to begin exploring new roles, like taking on an associate editor role, or being a contributing author to the IPCC, or contributing to the California Climate Change Assessment, or being a mentor to an undergraduate during the summer. The thing is that you don't want to become a shrub too early, right? You sort of want to have a good stem and a good trunk, and then begin to grow the foliage out a little bit later. So This is sometimes a challenge for people because they're, the world looks like a candy store, right? And all of that stuff looks super intriguing and super fun. And you can see that people senior to you are doing it, so why can't you do it earlier? You should do it, but I think the way to do that is somewhat from a position of strength. So make sure that you've gained a toehold in terms of building a solid publication record and a little bit of a reputation. And that reputation will begin to open doors in terms of people coming to you with opportunities as well. The thing you should be mindful of is you're sort of, another way of answering your question, Peng, is that you've got the balance right. If you are seeking opportunities at about the same rate that you're being asked to take on opportunities, those two things should be sort of commensurate, because it means the outside world recognizes you as a leader at the same time that you're trying to volunteer yourself to the outside world. So if those two things are in sort of, in lockstep, then I think you've got the balance about right. I don't have any secrets around time management, other than to just let you know that the things that immediately jump to the top of my stack as a division director are when you submit anything having to do where I represent a rate limiting step in terms of promotions, hiring, getting grants out the door, crises at the lab, safety, anything that involves stuff that, where my doing it or not is going to be a major impediment in terms of, money, people, safety, health, those things, jump to the immediate top of the stack. I don't know if that helps in terms of time management, but it's looking out for other people is basically what that comes down to. Colby, you have I hope that answered your question. Colby, you have a question for me.
Yeah, thank you very much, Bill. I was just wondering about your strategies for effectively collaborating in science, which can be, as you know, extremely competitive, where, sometimes you can end up sharing things with others, like data or models or equipment or even people, funding, ideas. And sometimes that's not, necessarily returned, but in other cases, it's the exact opposite. And so I was just wondering, what's your strategy for forming effective collaborations?
Oh, great question. I have, and I'm working on something like this now as part of this integrated mountainous hydrology activity that a number of people on the call are involved in. And the reason this is turning into a collaboration is that I've been asked to pitch this to the 13 federal agencies that are part of the U.S. Global Change Research Program. And so we very much, so I'm going to talk through a little bit of a specific example, but then show you how I'm pivoting to try to form a collaboration. So we initially we brainstormed this in-house as very much here's why Berkeley Lab, can totally do this thing with the stuff we've got going on in-house. And we pitched this to DOE. They like it a lot. They haven't given us any money yet, but they like it. And they've now asked me to brief the U.S. Global Change Research Program, which is 13 federal agencies, which represents several $1 billion worth of climate research a year on this concept. So now what I have to do in order for this to be effective collaboration is to walk into that room and not be, chin forward like we're the greatest. I'm now spending a lot of time figuring out what every person in that collaboration could contribute, and figuring out where their interests intersect, where our common interests intersect scientifically, so that when I go to speak with them, that I'm not only acknowledging, the skills that they have, the resource base that they're bringing to whatever we want to work on, the way that what I'm pitching to them is aligned with their scientific mission and their scientific interests, so they can see themselves and and their own interests and their scientific passions and what I'm trying to pitch to them. So it's very much a question of building collaborations is, it's not like walking into a room and saying, I've got this all baked. Would you like to add some icing? It's really like, let's go off and do this cool thing together. And by the way, there's a bunch of things I don't know. What do you know that I don't? And it's strikes me as like it's a collaboration, or like you've been, I don't know. It's almost like one of those puzzles where you've been thrown into a room together and you have to escape, and you have to work together to escape from the room. If you approach a collaboration, it's much more in that spirit. Like, we're only going to get out of here if we all work together. That works a lot better as a tone of communication. And where I've seen things fail is when institutions walk in and they've decided that they're going to be the leader, and everybody else can just sort of fall in line. That does not work so well. You also pointed to the issue around competition versus collaboration, and that takes some shrewdness on the part of all of us, and it also it takes some shrewdness with respect to, in particular, the DOE funding model. And so I don't want to go on and on about this, but basically the DOE funding model is set up so that amongst the Office of Science laboratories, we're sort of frenemies, right? Scientists at your and my level, well, actually, I'm part of the frenemy set. People who aren't division directors are supposed to be collaborating with each other, right? But once you turn management, so once you appear on the org chart of the laboratory, your primary responsibility is to the laboratory and not to, being a nice guy. And this is the reason why I'm now regarded correctly as part of management. So I'm regarded as when other institutions look at me, they don't look at me as a scientist, although I am, they look at me as part of management, and that is the correct way of looking at me. So you will run into situations where management will be running at cross purposes to the scientists underneath them. And I had this happen with a laboratory. I've had this happen with multiple attempts at collaborations with laboratories where their own management decided to run at cross purposes to the people I was trying to collaborate with. So that can be a situation where it's not the person yourself, the person themselves that are the problem, it's their management. So you need to be attuned to that. And the tricky thing with universities are a whole different ball of wax. And that's going to take me longer to answer than I have time for. But just within the DOE system, just be aware of the fact that you've got this weird dynamic that's set up by our business model, and also the fact that people like me at other laboratories aren't scientists. So Berkeley Lab is almost unique. My lateral counterparts at other laboratories don't do science at all. So I'm somewhat of an odd duck in that regard, because the Berkeley Lab expects us to lead by example. But yeah, I've had situations where laboratories have literally stomped all over their working scientists because the management wanted something. So just be very, very attuned to that. And I'm happy to help you work through that dynamic if it ever comes up. Other than that, I think, thinking about setting up a collaboration is something where people will want to collaborate with you as they see you. If they see you as it's reputation, Colby. I mean, your reputation precedes you, right? So if you're known as an honest broker, that's something that you never, ever want to lose. And I can assure you that once lost, it's very hard to regain. So, and I won't tell you any more stories around that. Any final questions for me? And I appreciate the fact that all of you have hung on for this long. So any last words of wisdom, or should we let Tracy wind this up? Because I've got another Zoom call on this line in 1 minute, 45 seconds. So any final words of wisdom?
Hey, Bill, this is Pankar.
Okay, this has to be quick.
Real quick. So one thing, what do you think you would say that changed the way fundamental science is being done since your graduation time and when you were in grad school and now?
Oh, thanks to Parker for the answer to that question is yes. It's changed quite a bit. I think one way it's changed for the better is that it has become, the internationalization of science has become a lot better. We have, the US can no longer rest on its laurels as the 800-pound gorilla. And the role of underrepresented minorities and women has changed phenomenally in the scientific fields since I graduated. That's all, it's been an incredible change for the better. The fact that Africa is coming up, that Asia has become a key partner, South America, that's all, it's revolutionized the way that we do science, and that's all to the good. So let me end on that note. Thank you all, and I hope you have a great rest of your week. Thank you.
Thank you, Bill, very much. And thank you to everybody who joined today. And we will be sending out the next talk that we have scheduled is Jens Bergholzer on April 8th. And I will be sending more information about that. And we'll also be sending the recording of today's session to all of you so you can watch it again.
Thank you.
Thanks, everybody. Have a great day.
Bye-bye.
Bye-bye.